The consumer group is a Redis-operated mechanism for distributing messages between members. Consumers can join a group simply by asking for new messages and providing their name. Once a consumer in a group reads messages, these are added to its pending entries list. It is up to the consumer now to actually process them. Every consumer is different, but ultimately, the processing of a given message can end in either success or failure. Like in real life, dealing with success is much easier than coping with failure. So let's begin with that. To deal with success, we first need to define it. Here's the thing. For a consumer instance to succeed, it needs to read the message, perhaps do some meaningful work with the data in it, and then get to the point where it is ready to process the next message. Put slightly differently, in order to succeed, the consumer needs only not to fail. The actual work performed by the consumer and any results obtained from it, while important in the grander scheme of things, are outside of the scope. Getting the message and surviving the processing is the only measure of success in the context of stream consumer groups. Consumer groups provide at least once message delivery semantics by default. We've seen how the consumer instance can read its spell, and that ability is what allows it to recover. But when the consumer does not fail, that is, when it succeeds processing a message, it needs to let the server know about that. This act, which is called acknowledgement, is just another task among other housekeeping tasks that the recipient does when it finishes its work. Recall that consumer A from group 0 requested a single message, the first message in the natural numbers stream. From the group's perspective, this message is currently pending processing. To signal that processing was completed successfully for that message, we acknowledge it with the XAC command. XAC is a straightforward command and has only one form of invocation. It accepts the name of the streams key, the name of the consumer group, and one or more message IDs that are acknowledged. The reply returned by XAC is the number of messages that were actually acknowledged, that is, removed from the group's PELs. The first message ID was in consumer A's PEL, whereas the 63-79 is an ID that I made up, so only one message was effectively removed. It is interesting to note that XAC does not require the consumer's names, only that of the group. While in most cases it will be the consumer itself doing the XACing as part of its successful housekeeping, that is not mandatory. This liberty makes it possible for other processes to acknowledge messages, which is definitely useful even if only for administrative purposes. Once we've acknowledged the message, we can verify that consumer A's PEL is now empty. At this point, since it has no pending messages to process, consumer A can issue a call to XRead group and use the greater than sign to get new messages. To recap this pattern, a consumer group member requests new messages but can fail at any time before acknowledging them. To avoid the loss of pending messages, the consumer first reads its history of pending messages before requesting new ones. This provides us with at least once message delivery semantics. In this chapter, we've reviewed how the consumer group's member operates to implement at least once message delivery semantics. Before starting, a consumer first processes messages in its pending entries list, and then switches to reading new ones. After processing a message successfully, the server-side context is updated by the consumer explicitly by sending an acknowledgement.